Hello, my 8th grade science class. I just want to make this video for this worksheet that you got today in class. There's a little bit more to this than, or that I want to kind of go over. Has to do with the problems here. So let's go through the first two examples together, and then I want you to try the next page for these problems, okay? And then this should help you to both study for the exam and kind of understand more about waves. So there's really cool things that you might want to know about waves. Just any of the waves we talked about: X-rays are waves, light waves are waves, microwaves are waves, ocean waves. You can kind of calculate this for anything, for any of those waves, if you know anything about its wavelength as well as its frequency, like how often it goes up and down. Okay, you can actually calculate with those two things. You can calculate the speed at how fast the wave is going. And there's a formula for that. So the wave speed is represented as the letter V, and V is equal to F times this weird sign here. This weird sign is wavelength, and that's usually calculated in meters, or it could be in centimeters, or in nanometers, nm, okay? Frequency, we're going to go much more in detail on this in physics and chemistry, but right now I'm going to give you super basic versions of these calculations to give you an idea of how to set up the calculations. But in the future, you're going to have to deal with centimeters and nanometers and so forth. But right now, we're going to do everything in meters. So that means that these waves are going to be fairly big, okay, which is not very common to all the waves that I mentioned before, like microwaves and X-rays and whatnot, okay? But I'm going to go through a few things with this for basic calculations on what you're going to have to calculate. So you want to calculate the speed at which the waves are going at, okay? And this is, I think, lifted sort of at your book, sort of from your book. I think bits and pieces of this, like this picture here, is lifted from your book. In this problem, I think I kind of made up and generated myself. So let's take a look here. How would you set up this problem? If a wave has a wavelength of 0.5 meters, so you want to set it up like this. The wavelength is represented by that symbol here, okay? And then it's 0.5. I can't figure out at the top of my head what that is. I think it's lambda, if I'm not mistaken. That's a Greek letter, okay? So it's 0.5 meters, or just m for meters, okay? And then a frequency is represented as f for now. In the future, you're going to learn that that's some other symbol, but for now, we're going to represent that as f. That's 3 hertz. Now, watch what I'm about to do. What, Mr. Wee? I thought you said the unit is Hz. How come you put 1 divided by s? Well, there's a really weird thing about this. Frequency is represented as either hertz or 1 over s. Pay close attention. 1 hertz, or hertz, Hz, hertz, hertz, like H, it's spelled with H-E-R-T-Z, okay? We shorten it down for Hz for how many hertz. 1 hertz is equal to 1 over seconds. Now, why do we have this weird symbol? That represents how many waves there are over 1 second. So that's a little weird, but think of it this way. If I put 3 over 1 divided by seconds, you sort of have to, sort of like when you look at mixed numbers, it's sort of like looking at 3 as being like a number that you can multiply a fraction, the numerator, in a fraction by. So it's 3 times 1 over s. That represents 3 waves for every 1 second. So that means the frequency, what that looks like. If you said the frequency of this guy is 3Hz, so don't write this on your paper, but 3Hz, or 3 over 1 over seconds, what that means is in 1 second, there should be like 3 cycles. 1, 2, and 3. That's how fast this wave is going at. When you learn about higher level physics and chemistry, you're going to learn that there's frequencies that are really, really high, like 3 million hertz, or 3 million over 1 over s. That means 3 million, like 3 million waves in 1 second. Okay, that's completely possible in real life. But right now, we're keeping our calculations to be pretty easy to do and understand. So let's see what happens. I need to find out what v is equal to, the speed or the velocity. What is the wave speed? So wave speed, we know, is f times lambda. So that means f times lambda, that's going to be 3 over 1 over seconds. I like using 1 over seconds, okay? The number 1 over seconds as the unit instead of hz, okay? You'll see why in just a second, because my answer that I get from the velocity is going to look pretty nice. 3 1 over seconds times 0.5 meters. If I do that calculation, I know that it's 3 times 0.15. If I do that in the calculator, that's going to be 1.5. And look what's going to happen here. 1 over s times meters. That's sort of like saying a fraction. You don't have to write this. 1 over 4 times like 5 is sort of like 5 divided by 4, right? Again, if you have like a sort of like a fraction multiplying to a whole number, it's sort of like multiplying this whole number as only to its numerator and dividing it by the denominator. Because if you remember anything about whole numbers, 5 is a whole number. If you wrote that as a fraction, that would represent 5 divided by 1, right? That's the same thing as just saying 5. And you'd have, and the rule for the rule of multiplying fractions is you always multiply the numerators and multiply the denominators. That's why as a whole number, 5 times 1 over 4, you can just straight multiply the 5 and the 1 and keep that on the top and keep the 4 on the bottom. Same thing with the units. 1 over seconds, that fraction of 1 being divided by over seconds as the unit, if I multiply 1 over seconds times meters, that's going to give me meters times 1 is meters. Meters times a number of 1 is simply just meters. And then on the bottom is per second. So that tells me that the speed of this wave right here, going this way, when it has a frequency of 3 cycles or 3 waves per second, and it has a length, a wavelength, if you actually measured the length of the wave, is 0.5 meters. If I multiply those two, we would find out the speed is 1.5 meters per second. That works out. So that's why I love putting in the units there. I know it's not easy when you're young, but when you do enough math, you're going to find that the value that you got out, you can check to see if it's right, if it makes sense. The speed should be in meters per second. In the future, you might learn things like miles per hour or kilometers per second. But right now, we're just learning meters per second as the wave speed, as a unit for the wave speed. Okay? All right. What if you had something that started with the speed? The speed is 20. So we have a wave right now. Okay? Pretend we have a wave in your head that's going at 20 meters per second. Again, you don't have to write out meters and seconds. Just put m over s at least. And then you have a frequency of 4 hertz. Again, that's 4 over 1 over seconds. Okay? And then we're trying to find out the wavelength. What is the wavelength? That means I don't know what the wavelength is. That's how you set up the equation. And then let's set up the formula that we know. V is equal to f times lambda. But we're trying to solve for just lambda or wavelength. So let's divide both sides by f. And then now you have velocity or wave speed divided by f is equal to lambda or the wavelength. So that's good. Now let's plug in the values because we don't have a value for wavelength, right? But we do have a value for meters per second, so a speed. That's 20 meters per second divided by 4 over 1 over seconds. So again, there's a little bit of review of algebra here for the unit, but I will end up getting 5. Now, what's my final unit going to be? So that's going to be my answer right there. 5 something is equal to wavelength. But let's look at the units. Now, the seconds should cancel out. But why? Okay, so that's going to be 20 meters divided by 1. So that's 20 divided by 4 is 5. And the units is meters per second divided by 1 over seconds. That should just give me meters. Now, why does that work? In case you don't understand, let's review fractions again. If you divide fractions, 1 over 4 divided by 1 over 4, there are 2 ways to look at dividing fractions. It's meters over seconds divided by 1 over seconds. You have this, meters divided by seconds over 1 over seconds. You could look at this as 2 ways. So I'm using numbers now, something a little bit more familiar. if you have fractions divided by each other, I've always learned that the numerators divide to each other and the denominators of the fractions divide each other. So 4 divided by 4 is simply, you can simplify that as such. Or you could look at it this way. If you take a fraction and you divide it by a fraction, you can also multiply it by its reciprocal. And again, those cancel out. Either way, what this means is that the numbers on the bottom here, if they're the same, they can cancel out. Look at over here, since meters per second has the same denominator of seconds as 1 over seconds, those units also cancel out. And then you take the meters and divide it by 1. Well, anything divided by 1 is itself, so that's why I have meters left over in the final answer. Does that make sense, though, that the wavelength is 5 meters? Yes, because I've already kind of spoken up here about this. Wavelength should be calculated in meters. In the future, you're going to learn how to do this in centimeters and nanometers, but you're not quite there yet. And in fact, maybe some of you are, but I just kind of want to go over this as if you shouldn't be familiar with that. But by next year, if you're going to take physics or chemistry or even some level of biology, they'll teach you this. I think any of the teachers here will teach this. Okay, these 3 problems I think now you should be able to solve, but let me go over one more with you just to kind of get a hang of this. Let's see, what if it was a frequency? Let's see, let's go over this one. What is a wave? What is the frequency of a wave? Again, I don't. So now frequency, I don't know what f is of a wave. If it has a speed of so it looks like we have 12 centimeters per second. You should be a little bit scared because we have not gone over centimeters. Oh dear, over seconds. We've only gone meters over seconds. But, and you're going to be like, do I have to convert that, Mr. Weed, to like meters per second? That's what you should be asking. It's okay if you didn't ask that, but you should be asking that. But pay close attention. If your speed is in centimeters per second, but your wavelength is also in centimeters, that's a good sign, because that should tell me that when I do the math, the centimeters will end up canceling out. It's a little secret. Well, let's double check and see how. Velocity or wave speed is equal to f times lambda, frequency times the wavelength of your wave. Remember, this is a wave that has a speed going at 12 centimeters per second and also has a wavelength. So again, so our fictional wave it's going at 12 meters per second. It's going pretty fast. And each of its wavelengths, if you measured it from the trough to another trough, or trough to another trough, it should be equally spaced at 3 centimeters. Okay, you don't have to draw this. Okay, I'm just kind of giving you a rough shot here, but we're asking what is this frequency? How many waves can we get in 1 second from this sucker? So here, how we set this up is we need to solve for f. So let's divide both sides by wavelength. That's going to be velocity divided by wavelength is equal to your frequency. Frequency we still don't know, but let's go ahead and substitute in the values of the wave speed. That's 12 centimeters per second divided by, let's check this out. Oh, the wavelength is 3 centimeters. What's that going to be equal to? So I know 12 divided by 3 is 4, but how are the units going to cancel out? Well, I'll say this, or I'll show you another example. What if we divided 10 over, let's say, I don't know, 10 over 2 divided by 5. What is that going to look like? So if you divide a fraction, let's see, so there's a few ways you can look at this. A fraction by a whole number. Okay, I'm looking at it in centimeters over seconds divided by centimeters. What's the final unit going to look like? You can kind of recognize 5 as being a whole number, and then if you made that into a fraction, it'd be 5 divided by 1. Again, if you divide fractions, if you divide it this way, what you're supposed to do is you're supposed to take the numerators and divide it by each other. So that's 10 divided by 5. That should give me 2. And then you're going to take 2, and you're going to take the denominators and divide them. 2 divided by 1, that is going to be, I believe that's just 2, and that should give me 1. Okay? That's one way you can do that. And in the same way here, you can look at centimeters over seconds divided by 3 over 3 centimeters. That could be centimeters over 1. So it could be centimeters divided by centimeters. Okay? That could be centimeters divided by centimeters, so they cancel out. And then seconds divided by 1 is seconds. So what we're going to do is, so centimeters and centimeters cancel out to 1. It could be 1 over, and then seconds divided s divided by 1 is just simply going to be seconds. That remains on the bottom, whatever your result is on the bottom. So maybe I should try a different fraction here. Let's see. Let's do 3 instead, okay? So if I did 10 divided by 3 divided by 10 divided by divided by 5, I would make 5 into a mixed or a fraction. It'd be 10 divided by 5 is 2. Okay, that's the numerator. And 3 divided by 1 is 3. So hopefully that makes it a little bit more clear what my intention is. If that confuses you, maybe you learn math this way. If you divided 10 divided by 3, or that fraction by 5, I would still make that into a fraction. But remember, if we divide fractions by fractions, what ends up happening is you would have 10 divided by 3. You would multiply it by the reciprocal of the fraction on the bottom, 1 over 5. That would give me 10 times 1, that's 10, and then 3 times 5 is 15. And if you see the common factor, you divide both the top and the bottom by the common factor. I think the greatest common factor is 5. You'd still get 2 over 3. Okay, but for the purposes of our example, okay, I think this is the easier way to do it. If it's a fraction divided by a fraction, you're going to take the numerators and divide them by each other. This is 10 divided by 5, that should give me 2. And the denominators, divide them by each other. 3 divided by the denominator of this fraction, which is 1. So it's 3 divided by 1, and that's going to be equal to 3. That's going to go on the bottom here. Okay, so same thing over here. Centimeters over seconds divided by centimeters over 1. That should be, I should divide the numerators, centimeters divided by centimeters. Those are gone. Okay, centimeters divided by centimeters. Anything divided by itself is 1. And then seconds divided by 1 is just going to be s for seconds. So does that make sense? 4 over 4, 1 over s. Remember, 1 over s is equal to hertz. And if you look back into the original sheet here, I did say a hertz is equal to 1 over s. So hopefully that makes a little bit of sense on how to do this. All right. So I want you to try number 1 and number 3, and I'm going to leave up a key on below this video link on the cover sheet so you can check your answer. Okay. All right, guys. That's all I have for you, and I hope that helps. You guys have a great night. And I hope this helps you for your homework. If you need help on the math homework, come and talk to me, and I can show you how to do even more complex calculations with frequency, wavelength, and so forth. All right, guys, take care. Have a good night.